let's look at the question that involving the system equations with different kind of solutions. Now, all the while, we have been dealing with the unique solution, which means we can find the value of x, y, and z respectively. Now, when is it that there is no solution, and when is it there is infinite solution? Let me just use the system equation with two variables to illustrate the scenario. Okay, now let's look at the unique solution first. The unique solution is such that I have two straight line and two different straight line, and then they intersect, and that will give you a unique point. That is the unique solution. So let's don't talk about this. We look at the straight line that goes this way, and let me just name it y equals to 3x plus 5. So if I were to sketch on the Cartesian plane, it will pass through 5 here. And on the other hand, I have another straight line that below or above, but they are parallel. Let's say this one is 1. So isn't it I can write the equation of this straight line as y equals to 3x plus 1. Okay, and they don't overlap each other. When they don't overlap each other, there is no point of intersection, there is no solution. But unless we use the graph sketching method or graph plotting method, then we can see very clearly. How about the algebraic way? So let's use the equation 1 minus equation 2 as usual. We use the substitution method or elimination method. You will notice that y minus y is 0. If you take equation 1 minus equation 2, y minus y is 0. 3x minus 3x is 0. 5 minus 1, you got 4. Okay, sorry, y minus y is 0. So you will have 0 equals to 4. And this one is considered inconsistent. How can that be? How can 0 equals to 4? Doesn't make sense. Therefore, this gives us the conclusion that the system has no solution because they don't overlap. They don't overlap. You get 0 on one side because they are parallel. You get a number on the other side because that is the difference between the y-intercept. So when you have a 0, okay, the left-hand side does not equals to the right-hand side, okay, then no solution. Or 0 equals to a number, inconsistent, no solution. Okay, this is under no solutions. All right, when is it infinite solution? If I have infinite solution, basically the two lines will intersect at multiple points. How do we get the multiple points? Y equals to 3x plus 5, let's say, same point, same line. I have another line, okay, which is the same straight line that overlap. Isn't it all the points on the line, they are actually the point of intersection? And for that red line, it can be 2y equals to 6x plus 10. Do you see the difference? It is just an expansion. I multiply both sides with 2 on this equation. So I have 2y equals to 6x plus 10. So let's test it out in terms of algebraic. Okay, algebraic equation. Otherwise, we can't see that they overlap each other unless we use the graph method. But let's use this one. We shall take equation 1 minus equation 2. But before you can minus it, you have to make sure they having no. We use substitution method, okay? We substitute 1 into equation 2. Because if you want to use the elimination, you have to make sure they have the same coefficient for one of the variables. So I use substitution method. Whenever I see y, I replace with 3x plus 5 equals to 6x plus 10, yeah? So on the left-hand side, when I expand it, I have 6x plus 10, yeah? And the right-hand side remain at 6x plus 10. So 6x group together, 10, you go there. You notice that 6x minus 6x, you get 0. Let me just write this out. Actually, you don't need to show this line. You can just go straight, 0 equals to 0. So you minus off everything, but you can't see, that means you can't even see the x and y and value. So in this case, it is infinite solution because they minus off every part of it. So infinite solution because they overlap. The lines overlap. It's as though as they are the same straight line. So if you have left-hand side equivalent to the right-hand side in terms of the constant value, then this is infinite solution. So with these two concepts, now we can solve this. We want the system equation. Okay, the question is such a way that find the value of A, find A, so that find the value of A so that, okay, the system has no solution, whereby in B it has infinite solution. Okay, so how do? We do the usual way to eliminate. Okay, let's call this equation 1, equation 2, and equation 3. Now, which one should I eliminate? I eliminate the y. Okay, I eliminate the y, so I shall take equation 2 times with 2 first. So I have 6x minus 2y plus 10z equals to 4. What is equation 4? Okay, equation 2 become equation 4 because I want to eliminate the y. So I shall just take equation 1 plus equation 4 because negative 2y plus 2y, they eliminate each other. So 6x plus x, we got 7x, y no more. Okay, 10z plus with negative 3z, so I have positive 7z equals to 4 plus with the 4 up there, that is 8. For this equation 5. And then since equation 2 and equation 3, the y value, the y coefficient, they are already the same. So I just take equation 2 plus equation 3. The y will minus off each other. I have 7x. And then plus the z portion, I have a squared minus 14 plus 5 of the z equivalent to a plus 2 plus 2. So a plus 4, yeah? Let's simplify this part first. 7x plus a squared minus 9z equals to a plus 4. Let's call this equation 6. So now how do we got to eliminate from 3 variable become 2. So now 2, we got to change it to become 1. I can just take equation 6 minus equation 5 to get rid of the x directly because they have the same coefficient for x, that is 7. So 6 minus equation 5, 7x minus 7x, no more. And then a squared minus 9 and minus 7, that is for z, is equivalent to a plus 4 minus 8. So we have a squared minus 16 of z equivalent to a minus 4. Okay. Now you see, we have reached, by right, we're supposed to get the value of z because we have eliminated the x and the y. So we'll come to here. So answer the question when there is no solution. Okay, when no solution, this side and this side, the coefficient, because this one, it will make the z will disappear. So a, in order for making the z disappear, a squared minus 16 must be equals to 0. Okay, so if a squared minus 16 equals to 0, we have a plus 4, a minus 4 equals to 0. Okay, difference between two perfect square. So our a can be negative 4 or 4, but which one? So since I left the left side to be 0, my right side cannot be 0 when there is no solution. The left-hand side, we want it to be inconsistent. How can 0 be a number? Right? This is inconsistent, so that this will give us the no solution. So just bear in mind, left-hand side shouldn't equals to the right-hand side. Okay, so when the a equals to negative 4, my right-hand side will become -4 minus 4. So I have -8. And when my A is +4, the right-hand side value will become 4 minus 4, which is equals to 0. Therefore, we want the value that is not equals to 0, because we know that the left-hand side has to be equals to 0 in order for us to have the scenario of either no solution or infinite solution. Okay, so in this case, the value of A equals to -4. As for B, infinite solutions, the left-hand side must be equals to the right-hand side. And since left-hand side is 0, the right-hand side must also produce 0. Therefore, the A value that we want is 4. That's it. So you have to understand the SOP to solve your system equation. That is to keep eliminating the variable until you get to the last variable. When there's unique solution, you are able to find the last variable and then work backwards to get back the other two variable. But when there's no solution, you notice that they are the same in terms of the gradient. They will minus off each other. So there is 0, then equals to a number. So it cannot be. It's inconsistent with the number system that we have learned. How can 0 equals to 4? So no solutions for this. Okay, whereby infinite solution, they will minus off each other because they are the same line after all. So equals, they will equals left hand side to the right hand side. 0 equals to 0. That is for infinite solutions. Okay, that's it.